Good evening. If there are people still in the lobby, if you'll start making your way into the auditorium, we're going to get started in just a few minutes. Thank you.
This is the stool. All right, judges are coming up. It's in the corner, like right in front of them. Yeah.
Go ahead. Anywhere I can see a green
Fair enough.
judge.
Yeah, I'll jump.
Lord, my load is heavy. Sorry? No, I just said, Lord, my load is heavy.
Can I get something out of there really quickly? They're all good to go. All right.
Yay! Liana, are those things going to be down there? Oh, that's for the people. Well, the Ray Jevons are going to come up and get them to distribute them right away. Okay.
Right after.
When after the video, they need to come up and start doing it. After the
Yeah, I think that's good.
Good evening, ladies and gentlemen. Welcome to the second annual championship round of FAU's 3 Minute Thesis. I'd like to give a big shout out to Katie Burke, who is our lovely red carpet hostess. will be getting her doctorate this December. To get us started, I would like to bring up onto the stage the queen of all things 3MT, the grand poobah of the Order of the Golden Owl, our very own Dean, Dr. Deborah Floyd.
Woo! Thank you, Professor McNutt. Good evening and welcome to the second annual Florida Atlantic University 3-minute thesis competition. Tonight we are celebrating the research of Florida Atlantic University graduate students. We currently have about 5,300 graduate students who are enrolled in 100 specialized programs in 8 of our academic colleges. 75% are pursuing master's degrees and 25%, of course, doctoral degrees. 2/3 of our graduate students are part-time, which means that they work and they have families and jobs and other commitments while they're going to graduate school. Almost 1,000 of our students serve as graduate teaching assistants, lab assistants, and in other important roles where they work alongside faculty and scholars. About 2 years ago, President Kelly launched a very ambitious strategic plan, the Race to Excellence, which was an ambitious plan which was improved by our Board of Trustees with pillars and platforms as a framework. President Kelly, Chairman Barber, and 2 of our pillar directors are championship judges this evening, even though the president said he doesn't feel like he can judge his students, so he's going to sit on the front row, and he's going to cheer all of you on. He will vote all of you as the top marks. Our strategic plan challenges us to strengthen our research presence and to support graduate students. Since day one, President Kelly has challenged us to approach our work with unbridled ambition and to be daring, to be bold, and to be FAU. Do we not get a cheer for that one? Thank you. We have accepted this challenge, and tonight is the culmination of an ambitious program that positions our university graduate students on a prominent worldwide stage via the 3-minute thesis. You may already know that an integral part of graduate school includes creating original research and contributing to the advancement of knowledge. As a part of studies, most graduate students must complete and publish an original thesis or dissertation project, research that is quite specific to their field of study and often takes many years to accomplish. And almost all students need money to help fund their brilliant research. But brilliant researchers do not always effectively communicate the value of their research to potential employers, to funding agents, to their family, even friends, not without a little bit of coaching and practice. So the 3-minute thesis program affords our students the opportunity to receive coaching about presenting their research in an expert and layperson fashion so that they can practice their communication skills that are so important for advancement in the career field. And, of course, that they can compete for scholarships, which they so desperately need to support their research. And I must say that our best recruiting tool for graduate school is our students, and you will see when they present their research. So what is the 3-minute thesis? How does it work? Have you ever had a conversation with someone who is smart, who is engaged in specialized research, but who you did not understand what they were saying? Right. Well, tonight's conversation will be different for you. 3-minute thesis students are challenged to present their research their specialized research in a compelling oration to a non-specialist audience. They will be challenged this evening to consolidate their ideas and their research discoveries concisely and in ways that have practical meanings for the discovery of knowledge. This is not an exercise in dumbing down or trivializing research. Rather, it is a challenge to distill their research in a 3-minute presentation that is understandable for individuals in and outside of their field. The 3-minute thesis process includes a panel of judges who are down front. Thank you, our judges. You'll be introduced to them a moment. And our audience, you, who will vote on the People's Choice Award. And as you know from your program booklet and reading the booklet, and I hope that you do, that this program is actually a program that was created at the University of Queensland in Australia, and it is implemented at hundreds of universities worldwide, including Florida Atlantic University. We know that people support what they help create, and the support for FAU's 3MT program is outstanding. Will you take just a moment, please, and to explore the pages of 3 to 7. Open your books, please. I know, this is like a class. Open your books. Please take the time to explore pages 3 to 7, and you will see the names of 45 judges, 23 steering committee members, 131 volunteers, and many others who worked tirelessly to make this competition a success. Continue looking in your booklet, if you will. That's okay. It can be fun. You can be messy and have a good time. And to explore and look at the 69, she's funny, isn't she? And the 69 donors and sponsors that are listed on page 7 of your program. These research scholarships and the refreshments and everything associated with this program would not happen without their support. So would you join me in thanking all of our donors, all of the folks that have participated in 3-minute thesis, please, with a round of applause. Tonight, our researchers will compete for these championship scholarships. Each competitor has won one or more prizes already in the preliminary heat competition. They are already winners. As you arrived in the auditorium, a slideshow presented photos from our preliminary heats that featured 90 competitors. Congratulations to all of the students that are listed on pages 8 through 13 of your program booklet. But tonight, only the previous scholarship winners from those heats will compete for the additional prizes. So before I turn the podium back to Professor McNutt, let's take 2 minutes to view a video of the 27 winners who will be competing this evening.
Wow. That was so inspiring. I didn't know whether to like cry or do an interpretive dance. It was like the Olympics. I would really like to thank Dr. Floyd and the Graduate College for recognizing the importance of scholarship money for students. I'm in my 7th year of teaching full-time academically, and I'm still paying off my student loans. $276.40 a month, probably for the next 8 years. That's like a case of Chardonnay that I'm just throwing out the door once a month, right? I'm being serious. At this time, we're going to go over the rules. If you will open your 3MT hymnals to the inside front cover, you will see a list of the rules. At this time, while I'm going over that, if our lovely redcoats are coming, the redcoats are coming, here they come, the redcoats are coming. If the red jackets, sounds like something out of the Hunger Games, if the red jackets would come and pass out the People's Choice ballots, that would be greatly appreciated. So the rules, it's very simple. No more than 3 minutes, speaking only, 1 static slide. They're not allowed any enhancements, such as props, costumes, dances, confetti cannons, pole dancing. This year we have cut out nudity. No nudity. Next, we have the comprehension and content slide. This is very, very important. This is the research element of the competition. Does the student have a clear process and understanding of their research? And can they communicate that research to a non-specialist audience? For example, if somebody's talking about the human coronavirus, I'm thinking about drinking a Corona on the beach and feeling sick. The human coronavirus is the common cold, right? So we're not dumbing down, we're just using language that a non-specialist audience can understand. Last but not least, we have the communication slide, engagement and communication. This is your presentation skills. You can be brilliant, your ideas can be brilliant, but if you cannot communicate those ideas, you're setting yourself at a disadvantage. Also, being able to communicate your ideas concisely within 3 minutes is also going to help students when you're applying for grants and you have to stand in front of a board of people and explain why your research is so important. While the People's Choice ballots are being sent out, please take a minute to look at this judging criteria so that you can evaluate and make your choice clearly for our tabulation purposes. To show you how to fill out these ballots, in case you are confused, we have an awesome video by Aaron Shapiro, who is one of our MFA graduates not MFA, he's one of our master's graduates in the College of Arts and Letters and a Pathways Scholar.
Hi, and welcome to How to Judge a 3MT competition video. My name is Aaron, and I am one of your MCs and professional 3MT judge. It's official, I have a pin. Let's face it, you judge everything, from TV shows to the outfits worn by strangers. Well, now's your chance to judge research that is changing the world. The 3MT competition is designed to give you, the audience, the opportunity to play a role in deciding what groundbreaking research should be crowned #1. Each competitor will have 3 short minutes to explain their research. You will have a list of contestants. After each speaker, draw notes next to and around their names. You will have to remember your judgments when making your final selection, so it is important to make these notes. Now, to complete your selection, you must, I repeat, must, completely shade in the square of the contestant you are picking. After it's all said and done, make sure you post on your Snapchat and Instagram stories to show where you were. Let the world know that you care about research and you're smart. So come and be a judge of the 3MT competition and show the world you care about graduate research. Make sure you check out your program booklets because inside we have the rules and judging criteria. On your official judging ballot, it's important to make notes. Make them here, or here, or here.
And speaking of judging, I would like to introduce our judges for this evening. We are honored to have some of South Florida's finest. We have presidents, doctors, esquires. Oh my. Right off at the top, we have our very own president of FAU sponsoring the championship scholarship, Dr. John Kelly. Dr. Patricia Anastasio, sponsoring our People's Choice Scholarship. She is a physician for advanced pediatrics of Boca. If you could stand, Patty, stand. You look too fabulous not to stand. Trustee Anthony Barber, a returning inaugural judge, yay! Chair of the FAU Board of Trustees and President and CEO of Barber and Associates. And one of my personal favorites, Marta Batmazian, who is on our advisory board of the Dorothy F. Schmidt College of Arts and Letters. Dr. Chamley Wick, who is the Assistant Dean for Undergraduate Research and an Associate Professor in Science, Chemistry, and Biochemistry. Dr. James Galvin, who is the Director of the Healthy Aging Pillar, Professor of Integrated Medical Science and Associate Dean for Clinical Research. Dr. Jason Hallstrom, Professor and Director of iSense, which is one of our 4 pillars at FAU, Department of Computer and Electrical Engineering and Computer Science. Tom Mersch, Esquire, a returning inaugural judge. Tom is also sponsor of first and second runner-up scholarships. He's a partner at Kelly Cronenberg Attorneys at Law. Dr. Miguel Montanez, a proud FAU alum and professor of mathematics at Miami-Dade College. And Kellen Smith, partner of MSI Consulting. Thank you so very much for doing this evening. For everybody, we're on to the competition. Are you ready? Are you ready? Buckle your seatbelts. It's going to be a bumpy ride. A list of your competitors can be found in the back of your 3MT books. All of our finalist competitors today have already won scholarship money, so they're already winners. We're going to have a very short intermission halfway through. Please make sure that your phones are on silent. Please take a moment to check that. However, please feel free to take pictures. You can take pictures and tag them at hashtag FAU3MT and follow us on Twitter at 3MT_FAU. And now, here we go. We're on to the competition. First up, we have Emily Stark from the Charles E. Schmidt College of Science, the Nose application in machine alpha. What? She is smart. The Nose application in machine olfaction. I gotta look that up.
Alexander Graham Bell said in 1914, "If you are ambitious to found a new science, measure a smell." Over 100 years later, and olfaction remains a relatively unexplored field. One thing is clear, however, the implication of such an advancement would be major. Consider the dog. Dogs have about 50 times as many olfactory receptors as humans do. This means that they're able to perform a wide variety of olfaction-based tasks in fields ranging from law enforcement to disease detection. I may be a bit biased, but my favorite task is what my service dog Nara is able to do for me, and that is detect rapid, potentially dangerous changes in my blood sugar level. A type 1 diabetic's blood sugar fluctuates wildly due to many factors outside their control. In fact, not only does food and insulin affect blood sugar, but so does factors such as exercise, sleep, the weather, and stressful situations like this one. So diabetic alert dogs are invaluable tools to type 1 diabetics. However, dogs like Nara are costly to train and maintain. This raises my experimental question: can we train a robot to do what Nara does? It's difficult, however, because we don't know exactly what she smells to alert me to my blood sugar. However, with recent advancements in artificial intelligence, this may be unnecessary. Consider how you train a dog. You begin with a stimulus, usually a verbal command, and then you pair that with an appropriate response or trick. Nara was trained in the same way, except that her stimulus was olfactory. It was a saliva sample collected during a rapid change in my blood sugar. Over time, this sample was shown to her, and she paired the alert response with this scent. She began to distinguish between what was an alertable sample and what was just regular saliva scent. To train a robot to do this, we're using a modified child's vacuum toy called Little Henry, complete with a suction tube, a bucket head, and yes, even a painted face. The tube brings in an olfactory sample, which is circulated through the Little Henry bucket, where we have placed olfactory sensors connected to a computer. These sensors output levels of gases detected, and that can be stored and analyzed at a later time. Now, to train Henry, we use the same process as with Nara. We show Henry what regular saliva samples smell like, and then we show him what saliva samples collected during rapid blood sugar changes smell like. Over time, and with enough computing power, he can start to learn via a mechanism in machine learning that we call deep learning what warrants an alert. However, the implications of a device like Henry transcend diabetes management. In fact, olfaction can open up a whole new depth of understanding. Alexander Graham Bell was enthusiastic in 1914 about olfaction, but he had no way of knowing the true potential of measuring a smell. Thank you.
Great, thank you, Emily. Next up, we have Christina Pimenta from the Dorothy F. Schmidt College of Arts and Letters, Democracy in China, Paradox or Possibility?
For most, the idea of democracy in China is one that seems highly unlikely, if not impossible. Well, I'm here today to challenge that assumption. So let me take you back to the year 1966, 17 years after Communist Party Chairman Mao Zedong established the People's Republic of China, and 4 years after the end of the Great Leap Forward, which ultimately ended in the tragic loss of 30 to 50 million lives. So now it's 1966, and Mao, trying to regain his once good reputation, institutes the Cultural Revolution. But it's at this point that we see him begin to remove those from power with dissenting opinions and persecute those who express any discontent with him and the Communist Party. So at this point, you're probably asking yourself, how could a country with this sort of history ever transition to democracy? Well, now it's 1977, and with the death of Mao and the consequent end of the Cultural Revolution, Deng Xiaoping and the new Chinese leadership institute a series of reforms to gradually dismantle these Maoist policies. And this is where things begin to get interesting, because since these reforms began, China has experienced steady and positive GDP growth. Urban population growth has also steadily increased, going from about 18% in 1978 to about 56% in 2015. In terms of education, the adult literacy rates in China have gone from about 66% in 1982 to about 96% in 2015. And these developments have substantially affected the attitudes of the Chinese people, especially those who were born into the improved economic conditions, leading scholars to expect that newer generations will be more pro-democratic than older ones. And with this growing social pressure, the Chinese government has responded with gradual capitalistic and democratic innovations. These include economic reforms, like the opening of markets and the reducing of trade barriers, as well as political reforms, like the abolition of life tenure for leaders, the use of inter-party democracy, and the implementation of village elections nationally. Now, with the strength and longevity of China's one-party regime, it's impossible to predict if the country will ever fully democratize, or how long it would even take for the government to do so. However, beneath China's seemingly rigid political structure, the social infrastructure for democratization is emerging and has progressed further than most observers realize. And while it may not have been Mao's plan for his legacy to eventually lead to the Chinese people becoming more and more pro-democratic, it's almost certain that we will continue to see these innovations develop throughout the country. After all, democracy is a process, not an end state. And as is often the case, the journey is more important than the destination. Thank you.
Thank you, Christina. Next up, we have Julia Robier, College of Engineering and Computer Science. Smell-O-Vision, using human odorant binding protein to measure landfill odors.
If you've ever driven past a landfill, you probably remember detecting an overwhelming noxious stench. Imagine having to live near that every day. Well, a lot of people do because of urban sprawl. And this is actually an environmental justice issue because those who live near landfills tend to be those of lower socioeconomic status and minorities and immigrants. Landfill operators need a better way to measure odor concentration at landfills, which is a very difficult thing to do because odor is such a subjective human experience. My research uses the human olfactory system as inspiration. I've taken human odorant binding protein and I've made a biosensor to detect odor at landfills. There are 3 components to this biosensor, which you can see on the far left of the slide. One component is the human odorant binding protein. This is a protein found in the nasal mucosa of all humans. It acts as a carrier molecule that carries odorants like a little submarine through the mucus to the receptor neurons to communicate with the brain. The other 2 components of the biosensor are this fluorophore, which is a fluorescent tag, and the odorant. So in the center part of the slide, you can see when the odorant binding protein is attached with the fluorescent tag, or the fluorophore, it glows like a glow stick. And we can measure this quantitatively using a spectropolarimeter. Now, when that system is exposed to odorants, that odorant binding protein lets go of some of the fluorescent tag and instead binds with the odorant. So the fluorescence decreases. So there's a negative decreasing relationship between the amount of odorant and the fluorescence. So the more fluorescence there is, the less odorant there is. The more odorant there is, the less fluorescence there is. And that way, landfill operators can use my biosensor to objectively measure odor at a landfill by detecting the level of fluorescence.
Hello, there we go. Next up, we have Brian Mcmahon, College of Education, Early Warning Systems Predicting Student Success.
Did you know that 1 in 4 students won't finish high school? What's particularly alarming about that statistic is over the past 30 years, it's largely unchanged, despite a plethora of research and policy to address that very issue. These are my kids sitting out there. If that number holds true, 1 of them won't graduate, and I'm not okay with that. They are the reason why I'm here tonight to share with you my research. As Floridians, we're all too familiar with early warning systems. Unfortunately, of late, it's more like Matthew and Irma, Harvey, those kinds of names. And while we like to complain about how accurate or inaccurate the cones are, considering they're a giant ball of wind and rain, I'd say they're pretty darn accurate. But there's another early warning system that you need to be familiar with. Did you know that every elementary and every middle school are required to identify and monitor students who are at risk? And how accurate is that? Unfortunately, we don't know. You see, the state of Florida took grounded research and then sprinkled politics throughout. And so we have a policy that looks okay on paper, but in reality, no one knows really how effective it is until now. You see, the issue with early warning system data is it relies on longitudinal data That is, we take recent graduates and non-graduates, and we go back in time to see what they were like when they were in elementary. To give you some perspective, the most recent graduating class, when they were their age, George W. Bush was president. And how applicable is that to today's kids? Well, my research uniquely addresses this issue. You see, I've actually been able to design an on-track indicator in 9th grade that successfully predicts graduation 80 to 85% of the time. In fact, when you're on track using this indicator in 9th grade, 92% of the time you're going to graduate. Now, in social sciences, that's huge. Well, we've been able to use that indicator now as a proxy for graduation. So in my research, instead of taking seniors and going all the way back to when they were in elementary school, we're able to just look at 9th graders and just go back a few short years to see what they were like. The results? Florida's model's not that bad, predicting about 70 to 75% accurate depending on the grade level. More specifically, if you're on track as a 3rd grader, you're 3.5 times more likely to be on track as a grade 9. In 8th grade, 10 times as likely. But that's just a start. We need to do a better job in our society of graduating students. And the first step is research like mine to identify truly students who are at risk. Our students deserve it. Jack, Grace, Eliana, Lilia, they deserve it. Thank you.
Thank you, Brian. Next, we have Natalie Bermudez, Christine E. Lynn, College of Nursing, exploring moral comfort in nurses.
This is the true story of a new nurse working in the hospital setting. An intravenous sedative was ordered for her confused and agitated elderly patient so that a vest restraint could be removed prior to being discharged. You see, patients cannot go to a nursing home until they've been free of restraints for at least 24 hours. Within just 10 minutes of giving the sedative and removing the restraint, the patient fell, sustaining a hip fracture and a laceration to the head. Afterward, the nurse came to me crying and said, I knew I shouldn't have removed the restraint and given the sedative. I just knew it wasn't the right thing to do. I should have questioned the order. So I asked her why she didn't, and she simply said, Natalie, I'm just a new nurse. Consequently, the patient was transferred to hospice care instead. A different patient outcome may have ensued had this nurse been comfortable acting on what she knew was right. Instead, she's at risk for moral distress. Moral distress in nursing is an issue that happens when nurses' ethical decisions cannot be translated into actions. Moral distress, while the incident is low, when it does occur, its effects are devastating to patients, to nurses, and to healthcare organizations at large. Moral distress can lead to nurse demoralization and job dissatisfaction. It can lead to increases in staffing turnover, contributing to an already existing nursing shortage. But of most concern, moral distress is associated with events and errors that lead to patient harm. Moral distress is a very serious issue, but there is hope. Moral distress has an arch nemesis, and its name is moral comfort. Moral comfort is a nurse's feeling of ease with decisions and actions related to ethical problems. However, moral comfort has not been widely explored. My research study focuses on the development and testing of an instrument in the form of a questionnaire to measure moral comfort, hopefully providing a clearer picture of the factors that promote it. Content expert evaluation and preliminary statistical testing of the instrument's accuracy have already shown promising results. This work that I'm doing is so important to the nursing profession and to all those who receive or will receive nursing care. Nurses' understanding of and actually living moral comfort will incite nurses to take actions that are morally sound no matter what. Moral comfort in nurses leads to safe nursing care and will promote positive changes in the practice environment, thereby positively impacting patient outcomes. Thank you.
Thank you, Marissa. Natalie, excuse me. Thank you, Natalie. Next up, we have Marissa Martinez, College of Science, Forecasting the Future of Coastal Ecosystems, A Bird's Eye View.
Coastal ecosystems support over half of the world's species and 3/4 of the human population. Despite their appeal to us and wildlife, coastal ecosystems are being degraded and lost at a faster rate due to climate change. Acceleration in sea level rise will make the devastation we've seen from recent hurricanes even more catastrophic. When we lose the coastal habitats that defend us from natural disasters, we lose lives. So it is imperative that we devise effective management strategies for coastal ecosystems. But how do we know if those strategies are effective? By monitoring an indicator that reflects ecosystem health and response to ecosystem change, we can track the trajectory towards or away from desired conditions. In freshwater ecosystems, we use wading birds like this little blue heron as indicator for wetland restoration. Their ability to raise young depends on the availability of food, which is controlled by the wetland's water conditions. In saltwater ecosystems, however, this link between wading birds and their environment is poorly understood. My research investigates this link to see if wading birds can be indicators for coastal saltwater ecosystems. We know that the length of a bird's leg restricts it to feeding in shallow water. So in my lab, a computer model was recently developed to calculate how tides change the amount of shallow water across the coastal landscape. The product is a shallow water availability map shown for the Florida Keys in the top left. The dark red areas around the islands in black is where the water is shallow for the longest time. When combined with other environmental predictors, we can predict where birds are most likely to forage, and that's shown by the map in the middle. But you can see in the last map that these birds are strictly using areas with high shallow water availability. I'm testing the hypothesis that this habitat use pattern is driven by a greater abundance of food in these shallow water areas. Without question, sea level rise will reduce the spatial extent of shallow water and shrink wading bird habitat over time. But habitat loss also happens overnight. The eye of Hurricane Irma tore through these red areas and laid waste to habitats and homes throughout the lower Florida Keys. More coastal areas just like this will need to be protected and restored in the face of increasing threats. But by using wading birds as indicators for these at-risk ecosystems, we can monitor the long and short-term effects of disturbances like sea level rise or Category 5 hurricane and guide effective management strategies. So if we can keep our coastal ecosystems alive, we can keep over half of the world's species and 3/4 of our population alive too. Thank you.
Thank you, Marissa. Next, we have Nicole Reed, College of Education, Game Time.
Hello. Think back to a time when you were participating in a game. The feelings of excitement, pride, maybe feeling a little bit out of your comfort zone, but still having a fun time. These are the feelings I am using to motivate students to participate in the OWL Nation Exploration Program, also known as the ONE program, a game-based approach to encourage decision-making. My goal is to help undecided students declare a major in their first semester. The purpose of this program is to help students explore early on so we can set them on a path for them to achieve their dreams and goals. Now, like all research, it started out with a question. How could I help undecided students declare a major in their first semester? I conducted some background research and found that games might be a great way to motivate students to participate in this decision-making process. I set out to test my hypothesis by creating curriculum and instruction that included game-like principles, such as levels, missions, rewards, and a competition, all to encourage the use of these resources. The program begins with an acceptance letter welcoming them. They then travel through 5 levels, which include missions, such as career and academic advising, and career assessments, both which have been shown to help students declare a major. They then compete in a presentation competition, one very similar to this, on an intended major or career. Now, the incentives for this program are those same feelings we were talking about before, of excitement and pride, but there are other incentives as well. If students can declare a major early on, they can start classes that they're excited about and graduate, let alone in 4 years, and get the career that they want. Now, the one program will not tell them what to major in, but what I've encouraged the use of resources to help them in this decision-making process. I want to know if this program can meaningfully help undecided students declare a major in their first semester. I'll be looking at graduation rates and change of majors throughout their time. I would hope that this program helps the students find their passion for being in college, because college is a fun time. But for undecided students, getting lost can be easy. That is why the One Program journey was developed. I believe that undecided students can declare a major in their first semester by simply playing a game. Thank you.
Thank you, Nicole. Next, we have Joseph Niederhauser, College of Science, The Secret Lives of Sparrows.
Our planet is facing its 6th mass extinction, and it is estimated that 30 to 50% of all species will go extinct by 2050. Therefore, it is critical that conservationists understand whether species are increasing, maintaining, or decreasing their numbers over time. The problem is that many species are either camouflaged or secretive, so studying them can be difficult at best. I work with the Bachman sparrow, which is one of the most critically, rapidly declining bird species in North America, but it has received very little attention. The reason is it spends much of its life hidden in the undergrowth of pine forests. For most people, you may never see one and only hear its beautiful song. Much of what we don't know about this bird involves their early lives and what happens after they leave the nest. We don't know where they're going. We don't know what they're doing. We don't know how many of them survive to adulthood. One thing we do know about this bird, it loves fire. I wouldn't call them pyromaniacs, but they prefer areas that have been burned every 1 to 3 years. And after 3 years of no fire, they start disappearing from the habitat. But why should we care if this bird disappears? Well, if they do disappear, then that means those forests are unhealthy and that more species are likely to vanish as well. The solution to understanding this bird better and to saving it and other species from extinction may lie in that beautiful song. My research uses that song to determine how far juveniles go after they leave the nest and then settle into a new area. I will do this by comparing adult males in the number of songs they share and the geographical distance between them. If I see more songs shared at closer distances, that means either that they settle in areas close to where they hatched, or they learn their songs after they settle into a new area. If I see more songs sharing at farther distances, then that means they're going farther before they settle into a new area. By understanding how far they go, we can figure out where to find them. And if we can find them, we can save them. Birdsong is not just beautiful music. It can help save millions of species from extinction. Thank you.
Thank you, Joseph. Next, we have Kirsty Tandberg, College of Science, Marine Natural Products as Cancer Therapies, Screening for Survivin Inhibitors.
Arguably, cancer is one of modern medicine's largest challenges. Last year alone, over 1.5 million people were diagnosed, and over 500,000 people died from those diseases. Clearly, there's a dire need for new, innovative, and effective treatment methods. I believe marine natural products is an excellent avenue to pursue in this type of research. Actually, about 50% of current cancer drugs on the market come from natural products. So there's already strong support for pursuing this type of research. Luckily in Florida, we're surrounded by the ocean, which is home to a multitude of incredibly diverse species capable of producing secondary metabolites or natural products. Since 1984, Harvard Branch Oceanographic Institute has been building a library of marine natural products they collect from their marine invertebrate and algae samples, which they use to test on a variety of diseases, including cancer. This brings me to my target, survivin. Survivin is a cancer protein target that is highly expressed in growing tumor cells, but not in surrounding differentiated tissue. This means that if we can find a drug that specifically targets survivin, we could significantly inhibit the growth of the tumor without detrimental side effects to the rest of the body. Survivin is the smallest member of the inhibitor of apoptosis protein family at only 16.5 kilodaltons, yet it plays a multitude of roles within the cell, including inhibition of apoptosis and promotion of mitosis. Displayed here is a general workflow of my project. I use marine natural products from my collected samples in an immunofluorescent screening assay. This means I use fluorescent antibody staining specific to my protein target, survivin, to visualize what's going on within my cells after treatment. I'm able to collect thousands of images for thousands of samples via this semi-automated high-content imager. I then take those images and pull a variety of data that gives me a really complete picture of what's going on within my cells in response to treatment. Once I find a hit or a compound that significantly reduces the expression of survivin, I take that compound into the chemistry lab. I isolate, purify, characterize it if it's a novel compound, then take that described compound back to cell biology, where I can use a variety of molecular techniques to determine the exact mechanism of action of how it's able to inhibit the expression of survivin in cancer cells. I'm confident that these techniques will produce valuable leads in the search for new, effective cancer treatments. Thank you.
Thank you, Kirsty. How's everybody doing? Are you learning something? That's good, because this is a college. Okay, up next we have Nandini Singh from the College of Science, Transformers of the Sugar Code.
Cancer, a lethal condition where our body self-destructs from within. A case where our body revolts and erodes away. Questions such as when, why, where have an adequate amount of uncertainty to them. Now recall, we have pioneered and overcome many pathogen-related diseases, literally with effectiveness and preciseness. However, cancer till today remains an enigma at large. The graph behind me shows that in 2010, there were 1.5 million cancer cases. In 2020, it's projected to be 1.9 million cases. Moreover, the cost of care and treatment for cancer was at $157 billion in 2010, and in 2020, it's projected to be $174 billion. That's a difference of $17 billion. If you did not know, that's equivalent to Iceland's GDP. So, is there a surefire method to detect cancer? Can I detect cancer at its very early stages? My answer to those questions is with carbohydrates and sugars. Now, everyone must be thinking what carbs and sugars have to do with treating cancer. And I was in the same boat. But turns out that with progression of cancer, your cells start to express these distinct set of sugars. Targeting those sugars is the fundamental basis of my research. Interestingly, a novel small lectin, which is a protein, can be isolated from the skin of this frog, and it's actually known to bind to these sugars. So part of my research revolves around synthesizing these very same lectins in my lab synthetically based on their amino acid sequences. So my research vision has two goals. One, make a library of these lectins so I can find that enhanced ideal recognition system for these cancer sugar sets. Two, use these lectins as a vehicle for targeted drug delivery. How does the latter work? Did you know that your nose actually has these sugars that can bind to my lectin? So if I had to deliver the drug into the brain of my cancer patient, I can attach the drug to my lectin and do that through the nasal passage. This actually opens a whole new dimension of targeted drug delivery into the brain, an idea, a notion that has been challenging until today. So in conclusion, I believe that my research can be the stepping stone towards early detection and prevention in cancer. And I'd like to add, my friend Bob the frog wasn't harmed from my research at any point or this presentation. Thank you.
I was worried about Bob. Thank you, Nandini. Next we have Brianna DeGroot, College of Science, Movement and Habitat Use of Spotted Eagle Rays Throughout Florida.
Sharks and rays have gained considerable scientific attention in recent decades due to their globally decreasing populations. Specifically, spotted eagle rays are listed as near threatened with a decreasing population trend. Although these animals are protected in local Florida waters, they are consumed throughout their range in places like Cuba and Mexico for protein, making it critically important that we fully understand these species' movement patterns and drivers of that movement, things like the effect of salinity, temperature, pH, and dissolved oxygen. Studying spotted eagle rays here in the Indian River Lagoon allows me to address these questions. I can look at movement patterns observed during dates when the canals are open and water is flowing from Lake Okeechobee into the Indian River Lagoon to those movement patterns observed when the canals are closed. This will allow me to pinpoint which water quality parameters are affecting movement and to what degree. Additionally, there's a last remaining clam lease in the Indian River Lagoon up near Sebastian Inlet. As these eagle rays consume bivalves such as clams, it is vital to understand these species' movement patterns and associated habitat uses to not only conserve these rays, but to also conserve this last stronghold for our clam populations. To look at movement patterns, I use a technique called acoustic telemetry, and this employs two items. The first is a tag or transmitter, and the second is an underwater listening station or a receiver. So after my animals are visually sighted from a boat, they're brought on board, captured, tagged, and released. Now this internal tag will emit a unique identification code every 30 seconds. As it's swimming throughout the water column, it will inevitably pass one or several of these underwater listening stations, which are able to correctly identify this unique identification code, which it stores along with the date and time. Now, as you can see based on the map behind me, all of these yellow dots that go along Florida's east coast, these are those underwater listening stations. And due to a collaborative acoustic telemetry network called FACT, I actually have access to all of this data. And this means I can follow my animals as they move up and down the east coastline and in and out of the inlets. One of my preliminary findings has shown that spotted eagle rays are temporarily displaced from the Indian River Lagoon during major weather events such as hurricanes. But more information is needed to determine that small-scale implications of normal weather events. The overarching goal of my project is to use this information to help make better informed management decisions on spotted eagle rays, both on a local and international basis. Thank you.
Thank you, Brianna. Next is Mikhail Gusenev, College of Business, Correlation Between Positive Mentality and Academic Success.
This is the picture of my grandma. Before I was born, Grandma was diagnosed with cancer. When I asked Grandma how she beat cancer, her reply was, "Honey, when your mom was pregnant, I told her I'm not going anywhere until I see my grandson." Today, my grandma is cancer-free, thinking positively that she'll get to meet yours truly. Seems to have increased Grandma's dedication towards fighting cancer, including taking medications on time and following up with a surgery. I've realized that positive mentality may affect our surroundings. In 1979, Robert Young, the dean of the School of Engineering at Princeton University, declared a research to prove that our mentality does affect physical being. After thousands of trials, Young's team documented significant evidence to prove and defend his research. My study reinforces Young's point through describing a 4-semester-long project that explored a correlation between students' positive mentality and their higher academic achievements. 67 students participated in my study, whom I've separated into 2 groups. Group A was to state only positive feelings about their assignments, such as, "I will do well on the exam." Alternatively, Group B was to speak negative thoughts about their assignments, something like, "I'm going to fail this exam, drop out of the university, be jobless and homeless for the rest of my life." I bet many of us can relate to this situation. However, I've identified that students with a positive mentality averaged an 8% grade increase compared to their previous semesters. On the contrary, students with a negative mentality were more likely to wait until the last second and averaged a 14% decrease. This phenomenon may be described by the term of visualization. By speaking positively, students subconsciously created ways, like dedicating more time to study, to accomplish a specific task of passing an exam. In contrast, students with a negative mentality waited till the last moment to start studying. This survey by the American College Health Association found that nearly 22% of students declared that anxiety, which can relate to negative mentality, had adversely affected their academic performances. My mission is to encourage educators to promote uplifting and positive environments in and outside of their classrooms. By applying my research, educators throughout the whole world will insight students who are ailed with discouragement and negative mentality to promote and maintain positive thinking and achieve higher academic success. Thank you.
Thank you, Mikhail. Next is Rachel Blatow, College of Science, Sea Turtle Development in a Changing Climate. Goldilocks temperatures are hard to find.
3 years ago, 80% of all sea turtle eggs laid here in Boca hatched into little sea turtles. Last year, only 40% of all sea turtle eggs hatched. This decreased hatching success means that fewer sea turtles are making their way out into the ocean to begin their life. And when only 1 in 1,000 hatchlings survive to adulthood, this could result in further population decline. The problem? Successful sea turtle development depends on temperature, and summer temperatures continue to rise. Take a moment to think back on the popular children's fairy tale character of Goldilocks. She didn't want things too hot or too cold. They had to be just right. Sea turtle embryos are a lot like Goldilocks. They too need temperatures to be just right. During the incubation period, if temperatures become too hot or too cold, development will cease and the embryo can die. So we know that temperature influences many aspects of sea turtle development. But what we don't know is what stages of sea turtle development are more vulnerable to these higher temperatures. My research aims to fill this gap in knowledge.
To do so, I collected unhatched eggs from nests laid here in Boca and dissected them to see what stage of development the embryo made it to before it died. I also utilized temperature probes so that I could determine stage by stage if temperatures were too hot or just right. What I found is that while survival decreased throughout the incubation period, all stages were equally vulnerable to these higher temperatures. The main driver of embryonic mortality was actually how hot and for how long those embryos were exposed to extreme temperatures. Of course, as climate change continues, it's more likely than not that sea turtle nests will be incubating too hot, rather during these just right temperature periods. This could indicate a further decrease in hatch success because more nests will be exposed to higher temperatures for longer periods of time. And so with my research, hopefully this will help lead the way to future management strategies that can better protect nests right here on our beaches from these higher extreme temperature ranges. And if temperatures can be just right again, then more sea turtles can survive, make their way to the ocean, and help in the recovery of the species. Thank you.
Thank you, Rachel. Next up, Brian Conklin, College of Science, designing a brain-computer interface that improves memory.
What if there was a Fitbit for your brain? What if it could also help improve memory? In neural engineering, these devices are called brain-computer interfaces, or BCI for short. There aren't any that can improve memory, but I plan on changing that with my thesis. This is important because as we age, our memories decline, sometimes leading to pathology like Alzheimer's disease or dementia. The goal of my thesis is to design a BCI that improves memory and combats the progression of these terrible diseases. Just like a Fitbit measures physical activity, a BCI measures mental activity. You can design a brain-computer interface using a cap embedded with electrodes that extract signals from the brain and sends them to a computer for processing. The signals I'm most interested in are those that arise when we use our memory. There are two main kinds of memory, long-term and short-term. Long-term is remembering things on a time scale of months or years. Short-term is remembering things on a time scale of minutes or seconds. When we use the information stored in our short-term memory to solve a problem or complete a task, we're using working memory. Now, if you're like me, you're probably tired of forgetting where you left your keys, but I'm here to tell you there's hope. Studies have shown that training on working memory exercises actually improves overall working memory performance in both older and younger adults. In fact, the performance improvement seen in older adults is similar to that seen in younger adults. But what's happening in the brain when someone's memory is improving? The answer may be found in the differences in brain signals arising during correct performance of a working memory task versus incorrect performance. I've discovered some differences in monkey brain signals as they were performing a working memory task. I used signal processing and artificial intelligence to find these differences. The differences can be thought of as features of brain signals that index working memory performance in monkeys. They may do so as well in humans. I'll be testing that hypothesis in a future human memory experiment. Imagine you've just been identified as being at risk for developing Alzheimer's by the time you're 65. What do? You can go on medication that doesn't really work, or if a BCI like this is available, you can begin using it. Your metrics will be shown on a mobile app, like you see on the screen above, and over time you'll see how those metrics change as you progress in your working memory training program. And then 6 months later, when you're reevaluated, hopefully your risk for developing Alzheimer's will have shifted from 65 years of age to 75 years of age. With just 6 months of training, you will have added 10 years onto your life. That's the goal. In 5 to 10 years, we may all be using BCI devices that improve a variety of cognitive functions, like learning, reasoning, decision-making. My work on memory is just the beginning. Thank you.
Thank you, Brian. Okay, you all have done very well as an audience. Nicely done. We're going to take a very quick break, like a 5-minute break. How long do you have? 5 minutes. Very good. See, I knew you were smart. Please come back quickly and we'll get started with the second round. right, everybody. Let's settle down now. I know it's exciting. I know you're learning new things, and we got to talk about it. You know, I have some of my students here tonight. I made them come. They're sitting over here. They're in the graduate college getting an MFA in acting, and they are performing in the Government Inspector, which is opening in a few weeks. It's funny, 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 funny. Gotta come. All right, do we have all of our judges? If you're not here, judges, let me know. Okay, they're all here. Physically. Okay, here we go. Are you ready, Bob? Okay. Next up, we have Bob Halstead, College of Science, Connecting the Dots in the Circle of Life, a fish story.
The Circle of Life, theme song to Disney's The Lion King, and something I'm expressly forbidden from singing during this presentation. Your loss. However, it is a simple concept that explains how most of the animals we're familiar with live their lives. You're born, you grow up, you make more of yourself, and you die. However, quickly it's more complicated from there, as each species has their own path to follow. Figuring out how the circle works for any individual species is critical for understanding it, and that's what I intend to do for bonefish. Bonefish, seen here, live in shallow coastal waters in the tropics. Bonefish have been popular among recreational anglers in the Florida Keys for decades because of their fighting strength and long runs when hooked up. These anglers were among the first to notice when the populations in the Keys began declining, so they started asking questions. They didn't get a lot of answers, so they started funding research to learn more about their favorite fish. Thanks to their efforts, we've learned more about bonefish today, like their larval stage lasts from 41 to 71 days, juveniles like to grow up in shallow protected bays, and we know where the adults gather in the thousands during full moons to spawn at depths of over 50 meters. However, despite these advances, questions still remain. My research is looking to answer some of those questions by spawning bonefish in captivity. Currently, there are 34 bonefish in the tanks at Harbor Branch Oceanographic Institute. By controlling the length of light and temperature, important seasonal cues, I can tell the bonefish roughly what time of year it is. So I keep them happy and well fed until winter and spring, which is when they normally spawn. Then I turn the lights off, put some berry white on, and wait for the magic to happen. If that romantic evening is not quite enough to get it done, I can use fish hormones to try and help spice things up a little bit. Unfortunately, my attempts so far have been unsuccessful, but I have high hopes for the upcoming spawning season. Successfully spawning bonefish, an important achievement in its own right, also opens the door for future research into other life stages. For example, describing egg and larval development, which I also hope to achieve. This information will provide important reference for future spawning and rearing efforts. Ultimately, I hope that my research will help us spawn bonefish and raise them up into juveniles. Having this capability would be an important tool for fisheries managers for stock enhancement. Bonefish remain an important part of the culture and economy in the Florida Keys. Protecting bonefish protects this legacy, but also the habitats that they live in. While I regret that my research doesn't answer all the questions about bonefish that we still have, I hope the questions that it does answer help make the life cycle a little clearer. Until then, the circle of life moves on. Thank you.
Thank you, Bob. Next, we have Nicholas Davenport, College of Education, Mind Body 1, Training the Brain by Training the Body.
From Sigmund Freud to Donald Hebb, all the way to Arnold Schwarzenegger. Now you're probably thinking, what do any of these guys have to do with each other? Now the key word there would be thinking. Now there's a link between working out the body and working out the brain, but most think exercise is just for healthy heart health and losing fat. But researchers are starting to say that this just may be a byproduct of what exercise does for the brain. But why? Well, ask, why do we even have a brain? To think, to create, show emotion? How about movement? For example, for the simple to complex movements to interact with the environment around you, to the contraction of smooth and cardiac muscle to keep the organs functioning, all the way to me giving this presentation. Now imagine if I stood here with no body language, arms at the side, it'd be hard to get my point across, or if the muscles of my mouth did not contract, I wouldn't make any good points, would I? Now, this brain-body connection is an evolutionary trait from our ancient ancestors who had to walk miles a day while predicting which way their prey went and remembering safe places to hide for survival. Now, this combination of physical activity and cognition led to a physiological adaptation that we can harvest through exercise today. And that adaptation is the production of BDNF, brain-derived neurotrophic factor. Now, what BDNF does is causes neuronal growth and protection of brain cells, primarily in the hippocampus. This is the brain center for long-term memory and learning. Now, researchers have, well, simply put, basically, more brain cells, better cognitive functioning. Now, researchers have put BDNF on neurons and seen that they grew more branches. There's even a school in Chicago that put a uniquely placed exercise program before their toughest classes, and they saw an increase on an international test against schools such as in Japan, China, and Korea, and they scored #1 in science and #6 in math. And you can see that's mighty impressive given the field they were in. Now, the goal of my research is to go back to our ancient roots and integrate exercise with thinking. For example, I do different types of drills that requires, for example, a red cone, blue cone, and a yellow cone. I'll assign them numbers, so red cone 1, blue cone 2, yellow cone 3. I have the participants sprint to the cone based on the number called. Now they're using working memory while simultaneously exercising, using this BDNF and cognition to make the neuron connection stronger. Now these implications can help with Alzheimer's patients with prevention of cell death, or even in tactical populations with helping military officers and police react better under stress in high pressure situations. Now, I just want you all to close your eyes for just 1 second and just envision a world. Instead of giving a kid with ADHD a pill, you would just simply prescribe some push-ups and a math equation. Thank you.
Thank you, Nicholas. Next is Rachel Salas, College of Science, Singing Behavior in the Northern Cardinal.
Birdsong. We've all heard birdsong. In the spring, it becomes the almost ubiquitous background noise to our early mornings. But do we ever stop to ask, what is birdsong? Why do birds sing? Well, one of the more well-known reasons is to attract a mate. A male will sing, a female will listen, she will gauge certain qualities about him, and she will evaluate his potential as a mate. But song isn't just about the females. No, a male can also listen to other males and evaluate their qualities, and they will use their songs to fight. It's not just sex, it's violence. And it's violence that allows them to engage in these confrontations that aren't physical, and they're not injurious or deadly. For my research, I aim to address whether or not male cardinals are capable of recognizing differences in vocal qualities and responding accordingly. But first, how do we recognize and conceptualize songs in birds? We're not birds, so we don't exactly understand what they're getting across when they sing. One method that we do use is called singing performance, which relates the speed at which a bird sings to the range of frequencies or pitches they sing at. Imagine a bird singing. They can either sing very quickly or with a large range of frequencies. But there's a trade-off here. If they sing faster, they lose some of this range. It becomes more physically demanding to maintain a fast song while maintaining a large range of pitch. Thus, we consider a high-performance song to be a song that is fairly quick with a relatively large range of frequencies. And research suggests that birds are capable of recognizing differences in vocal performance. So, for my research, I played both low and high-performance song to wild birds, and I'm analyzing the responses. For example, if they heard a high-performance song, did they respond with a high-performance song? Or did they respond more aggressively? If they heard a low-performance song, did they just sort of back up because they didn't perceive that bird as a large threat? So, by now you're all very aware that birds use song to both attract mates and be aggressive. But there's actually a lot we don't know about bird communication. My research will bolster our understanding of birdsong in these aggressive contexts and help to answer the question, why do birds sing? Thank you.
Thank you, Rachel. And now we have Melissa Sannon, College of Education. Who's your Cody?
Meet Cody, charismatic, charming 24-year-old with a wonderful smile. He's loved by his family, his friends, and his fellow colleagues. Despite being loved by so many people, Cody kept a secret: depression. In the summer of 2016, Cody visited Florida Atlantic University for the Appreciative Advising Institute, hosted by his grandmother, my advisor, Dr. Jenny Bloom. During Appreciative Advising, Dr. Bloom always poses the question, who's your Cody? To encourage advisors to think of their students as a real person with love and respect. Earlier this year, Cody performed an act of self-injury. He died by suicide. Mental health is a topic that we need, no, that we must discuss more openly. Research at Emory University studied 1 out of 1,100 college students die by suicide annually on college campuses. 1 out of 10 students develop a plan for suicide. According to the Center for Disease Control and Prevention, suicide is the second leading cause of death of individuals 15 to 24 years old. So that brings me to my research. I took a national data set of 144,000 college students. I used SPSS to run statistical analysis. And I found that suicide ideation, the prevalence rate in public and institution was small differences. Currently, I'm doing a qualitative inquiry study with resident directors and administrators to see the effects of suicide on college campuses. All of my participants said that they wish that there was more programs and conversation about suicide ideation. A common misconception is having the conversation of suicide will provoke the student's act. The research tells us that we need to have these awkward, uncomfortable conversations. One suicide is one too many. So, who's your Cody? Thank you.
Thank you, Melissa. Next up, Eric Neves, College of Engineering and Computer Science, multiple vehicle-based underwater sensing.
My name is Eric Nieves, and my talk is on multiple vehicle underwater sensing, where more than one artificially intelligent robot collaborate to find an object underwater. An analogy of this collaboration found in nature is shown in the top left figure, where a group of fish and a shark interact. These fish have the ability to sense vibrations underwater, and when one of these fish sense a shark, it can convey the message to the rest of the school, allowing them to all collaborate and escape. So the idea is to employ this idea to a network of vehicles, and such as shown in the top right figure, where a group of technology is used to paint the idea of an ocean environment. So you might ask yourself, why not just use one powerful vehicle that has everything you need on it? The answer to that is found in a typical workplace. Imagine if this was the workplace, and I came to one of you and said, "You're just great, so I'm going to give you the entire company workload because I think that you can handle it." what would your response be? You'd probably slash my tires. It's much more efficient to take a group of specialized workers, each with an ideal skill set, and get them to work together to accomplish the job. In a similar fashion, I would like to use multiple vehicles to find a metallic object underwater. An application of this research could be to find the dangerous and sometimes completely forgotten about underwater mines shown in the bottom right figure. The idea is to first use the magnetometer shown in the bottom middle picture. This can sense metallic objects over a large range. Once it has done so, it can convey that message to the vehicle in the bottom left figure that uses sound waves to paint a picture in the ocean, thus confirming that a mine is there or not. So the future of this is to keep increasing the efficiency of communication between these machines, while at the same time hoping that I don't create a real-world Terminator. Thank you.
Thank you, Eric. Up now, Felicia Cooper, the Charles E. Schmidt College of Medicine. Sudden death due to pulmonary embolism arising from occult ovarian cancer.
Hello. Today I'll be presenting a case from the Palm Beach County Medical Examiner, where I worked over the summer doing autopsies. Yeah, that's right. I saw dead people. This case is about a 54-year-old woman who was found dead suddenly at her workplace in Jupiter. She had no medical history and she hadn't seen a doctor in decades. But over the past year, her husband said that she had been complaining about back pain, abdominal pain, weight loss, hair loss, and vaginal bleeding. So the first finding on her autopsy is shown with the red arrow. This is a big blood clot in her lungs called a pulmonary embolism. Chris Bosch had this. It's when a clot breaks off from somewhere in the body, then travels up through the heart and gets lodged in the vessels that feed the lungs. Eventually, the blood can't pick up its oxygen from the lungs, and so the tissues die, and the person can die. Usually, these clots come from the deep veins of the legs, which is why people tell you to get up and walk around on airplanes. So now the question became, where did the clot come from? Well, that's when we opened up the patient's abdomen and found this massive ovarian tumor, shown with the purple arrow. This tumor weighed 2,200 grams, nearly 5 pounds, the size of a cantaloupe. To give you an idea, the patient's brain only weighed 1,200 grams, so this tumor weighed almost double the mass of the patient's brain. The blue arrow shows what's left of her fallopian tube. When we take the tumor and we look at it under the microscope, we can see that the cells are whorled. They don't have any sort of pattern or layering to them. And that's typical of cancer cells. They just start growing willy-nilly without any organization. So now we can conclude that the patient's blood clotted more than it normally would because of the cancer, and that the tumor pressed down on the veins in her abdomen, causing the blood to pool. Eventually that pooled blood clotted, and that clot traveled up through her heart and got lodged in the vessels that feed her lungs. Now, this case is important because it teaches doctors and medical students about what can happen when ovarian cancer is left untreated. And it's also a strange way of getting a pulmonary embolism, but still an important one to consider. Maybe we should screen all survivors of pulmonary emboli for underlying cancer. Thank you.
Thank you, Felicia. Next, we have Gabriela Tortolido, College of Arts and Letters, Marianne from the Tropics, Finding the Feminist Between the Lines.
Hello, my name is Gabriela Tortoledo, and I am an international student from Caracas, Venezuela. And this summer, I had the honor of portraying Marianne Dashwood in FAU's production of Jane Austen's Sense and Sensibility. For those of you who don't remember this story, it takes place in England in the 1800s, and it's about two sisters struggling to find love and ultimately marriage. So, you can imagine when I get to school the day after auditions and find out that I am cast as Marianne Dashwood, one of the two sisters. And I'm immediately terrified with the challenge. How am I, a loud, contemporary Hispanic woman going to portray this dainty little English lady from 200 years ago? Fortunately, the answer came to me very early in my research process: feminism. As it turns out, Jane Austen, the daughter of a clergyman, worldly renowned for her frivolous romantic novels, was actually a secret revolutionary of her time, heavily influenced by the grandmother of feminism, Mary Wollstonecraft. Feminists today have an ambivalent relationship with Austen due to the fact that her lead character's goals always seem to revolve around marriage. However, we must consider that they lived in a society where women were not even allowed to work, and the simple act of defiance to an arranged marriage, seeking to pursue a union based on love, was completely unacceptable. As I began to deconstruct the script further, I found evidences of Austen's advocacy for equality in many of the ideas expressed by Marianne. For example, Edward, Hamlet is not making polite conversation. In this speech, he is all of mankind, all of humankind, railing against the forces that would keep us tame, that prevent us from acting upon our soul's truest impulses. The speech not only makes a point to differentiate the use of humankind over mankind, but in a way also summarizes Marianne's understanding of the world by comparing herself to the most renowned male character of all time, Hamlet. Having grown up in a conservative Hispanic society, I was oppressed because of my gender. I grew up fighting for equal opportunities, and it was this struggle that allowed me to identify with Marianne. By becoming Marianne, I was thrilled to share my findings on Austen's precocious views on feminism with hundreds of theatergoers. It allowed me to remind my audience that women are being oppressed not only in my Hispanic culture, but in this American culture, and in cultures all around the world. My research supported my belief that women have been fighting for equality for over 200 years. Thank you.
Thank you, Gabriella. Next up, Boris Tizak, College of Science, Sea Turtle Sex Ratios in a Changing Climate.
Scientists estimate that 200 species go extinct every day. Now, that's not going to slow down unless we do something about it. Take sea turtles, for example. They've been around for over 100 million years, and now all of a sudden, they're in the list of animals that may go extinct in our lifetime. That's crazy. And one of the biggest threats to their survival is a rapid increase in temperature. And that's because for sea turtles, it's the temperature of the sand while they're still in the egg that determines whether they're going to be a male or a female. Cool temperatures produce males, and warmer temperatures produce females. Or hot chicks, cool dudes. That's how I remember it. But the question is, what do you think is going to happen if the temperatures continue to increase, especially here in hot, sunny South Florida? Well, we expect to see a lot more females, right? In fact, in our lab, we estimate that over 95% of all the turtles that hatch in Florida are female. Now, if you're a young man walking into a bar, you love those odds. But unfortunately, in nature, it doesn't work that way. So what we're trying to figure out in our lab is, what is the sex ratio of turtles in Florida? Well, that's a really difficult question to answer, because male and female turtles look exactly the same until they're about 25 years old. And currently, the only technique that we have to identify sex in turtles requires invasive surgery or to sacrifice the animal, which is the last thing you want to do when you're trying to save an endangered species. So that's when I told myself, there has to be an easier way to identify sex. So I went back through the literature to figure out, well, what do we know about sex determination in turtles? We know they're not like humans. They don't have sex chromosomes. In fact, male and female turtles are genetically the same. They have the same set of instructions. What changes is which pages of that instruction manual are read, or which proteins are expressed. So it's a difference in protein expression that drives sex. So I had to find a protein that would be found only in one sex and not the other. But the tricky part was, how do I do this without hurting the animal? Well, I looked through hundreds of different samples and tissue types, but we finally found a protein called Anti-Mullerian Hormone, and it was only found in samples of males, in blood samples in males. So what we have now, it's an easy and a reliable technique that allows us to identify the sex in turtles the same day that they hatch, and all we need is a single drop of blood. So this could be done anywhere, at any beach all over the world. No more invasive surgery, no more sacrificing turtles, just one drop. So now that we can identify sex, we can step in. If we know for a fact that there are too many females, well then we can do things like cool down the nests to make sure there's enough males to keep a healthy population going. So for so long we have been part of the problem, bringing animals like sea turtles to the brink of extinction. But I believe that with this technique, we can finally become part of the solution. Thank you.
Thank you, Boris. I would just lift up the sea turtle shells. Right? It's a long night. And they only gave us water. Next, we have Michael Miller, College for Design and Social Inquiry, Diffusion of Mission-Related Investing by University and Foundation Endowments.
Raise your hand if you've ever heard of impact investing. Yeah, I'll go with less than half, right? So I have three goals tonight. First is that everyone walks out of here with at least a basic understanding of what impact investing is. Second, I'd like you to know why I'm so passionate about the idea of universities and foundations becoming active impact investors. And third, I want you to appreciate the opportunity that exists for every person in this room to do impact investing. So first, what is impact investing? At its most basic level, impact investing is the consideration of both financial returns, which are important, but also the social and the economic impacts of those investments. Whether it's air quality or opportunities for education or housing, it is a double bottom line investment. And the important thing to remember is that all investments are impact investments. We're just rarely mindful of what those impacts are. So if I ask again, who here has heard of impact investing? All right, there we go. We're on a good roll. All right. Second, what does this have to do with foundations? Imagine a foundation with $100 million. If it's like a typical foundation, $5 million of that will be spent every year on grants and scholarships and philanthropic goals, and that's great. But the other 95% of that money is invested. It's invested in stocks and bonds like many people in this room are invested in. And a conversation emerged about 10 years ago around the question of how can we use this other 95% of money to more directly impact the goals and the missions of our foundations. And it's from this conversation that impact investing emerged. And it is a powerful idea. It has the potential to unlock vast sums of capital for solving the world's greatest problems. The research project that I'm currently working on is looking at foundations that currently do impact investing. What is the board composition like? Where are they located? How big are their staffs? And I'm trying to understand what are the forces that govern this behavior of impact investing in foundations. But third, and this is important, we can all be impact investors. There are a million impacts out there that you can be considerate about and 1,000 different ways to measure them. Google impact investing when you get home, and I really hope you do. But what you measure and how you measure it is all secondary. At its core, at its heart, impact investing is about being mindful of the impact that your money is having on the world. And that is something that we can all do. Thank you.
Thank you, Michael. Next is Keith Murphy, College of Science, using light to control meal size.
So I'm driving the other day and my AC is broken, so my window is down, and the delicious smell of Chick-fil-A comes pouring through my window. Now I had already eaten, so I'm not gonna go there, but somehow I ended up in the drive-thru. Keith, you're on a diet, I'm telling myself, so I'm not gonna order anything, but as this story goes, I got a 12-piece chicken nugget with fries. But at the same moment, I had to ask myself, am I in control of the decisions that I've just made, or is Chick-fil-A? And I would argue that the food industry has been taking advantage of our hardwired desire for certain tastes, textures, flavors for so long, driving the obesity epidemic onto 2 billion people in this world. So I don't like to sound like the mad scientist, but maybe it's time that we fight mind control with mind control. For right now, all we have are drugs. Drugs that attempt to turn on the region of our brain that tells us when we're full. But a drug will bathe the whole brain, incidentally turning on regions we didn't intend, causing really terrible side effects. And not just that, the drug just sits there, hammering away at our brain, and eventually our neurons wear down. They stop responding. So it's really no wonder drugs don't work all that well. They're not mind control, but is there anything better? Now, a few years back, a few scientists showed the world that you could genetically encode a light-sensitive molecule into any neurons you want, effectively allowing us to activate these cells with flashes of light. Now, years later, they took fruit flies as a genetic model to show that you could use this tool to control all kinds of behaviors. You could make flies walk in circles, go to sleep, fight with each other. But I wanted to know, could you use this technique to make an animal feel full? So for months on end, I began searching through thousands of neurons, eventually finding cells that detected the stretch of the gut. And I genetically encoded one of these light sensors into those same cells and just those cells, getting rid of the spatial problem of a drug. But we still needed a way to turn them on at just the right moment. So I began building a machine that would watch dozens of animals at a time. And when it noticed any individual beginning to eat, it would bathe that animal in a field of light. Now, if they didn't have the light-sensitive molecule, they seemed not to notice at all. They just keep eating. But for those who did, they would quickly retract their mouth, wipe off their legs, and just walk away from the food. Using this technique, we showed that we could reduce the consumption of these animals by 40%. Now, this is a stepping stone. This is hope that someday we can use gene therapy to encode these light sensors in our own gut stretch neurons so that we can feel full with the mere application of light, so that we can end the obesity epidemic, so that the next time you're walking on campus by that Chick-fil-A and that smell reaches out and you start walking towards it, but you're not really sure why, you're just going to turn on your light and you're going to walk right by. Thank you.
Thank you, Keith. I feel thinner. Next, we have Daniel Creed, College of Arts and Letters. You are what you read.
If you grew up in a house that was anything like mine, at some point your mother looked at you and said, you know, you are what you eat. And it doesn't look like any of us turned into a bag of chips or a can of soda yet. But we're smart enough to know that Mom was right anyway. My research takes this and looks at it from a textual manner. We look at the way people interact with the text that they read. When we approach a text that we've never encountered, in a setting we don't know, we use our worldly memory, the things we already have inside us, to look at that text and figure out where we're supposed to be. So that when the hobbits walk into the prancing pony, you're like, I don't know the prancing pony. But you know the smell of sawdust. You know the smell of leather. You know what stale ale in the air probably reeks like. And you use this experience to set yourself into the text. Now, science justified Mom's position, and it tells us that if we move memory that way, we must also expect memory to move back. If we approach the text and we believe that it has a cognitive value, if we think there's a deeper meaning to it, and we invest ourselves emotionally in the characters on an affective side, Gary Wolfe says we believe in the world of the text. And we can move to deeper belief. My contention is that that deeper belief creates memory, not semantic memory, Not just the recall of I know 2 + 2 is 4 because that's the last math class I took, but the idea of experiential memory. Thus, what the hobbits went through in the Shire, walking across the world to destroy the ring, while it might seem silly, prepares us for what we experience in life. As Chesterton said, fairy tales don't exist to tell children that dragons are real. Children already know dragons are real. Fairy tales exist to tell them that a dragon can be beaten. In our world today, we'll probably never get asked to go destroy a magic ring. Let's hope, anyway. And if a wizard shows up at your house, make sure you're asking your friend what kind of mushrooms they put in the chicken marsala. However, though you may not expect your Hogwarts letter to arrive and tell you that you get to go to a wizarding school, you can look at your college admissions letter and find a bit of magic in your own world. This should change the way we look at the aesthetic experience throughout. Thank you.
Thank you, Daniel. Last but not least, Brandon McHenry, College of Science, Zombie Bacteria, Understanding the Viable but Non-Culturable State of Vibrio vulnificus.
So, it's no surprise that in Florida, people love the beach. But some of you may have been afraid to go in the water after hearing headlines in the news like, flesh-eating bacteria kills Florida swimmer, or beachgoers beware. These stories are talking about Vibrio vulnificus, a type of bacteria that causes potentially fatal wound infections in a select group of the population. In fact, these bacteria are responsible for about 30 hospitalizations and 10 deaths in Florida each year. Now, to put that into perspective, that's actually 10 times the number of people that die from shark attacks around the country. What makes these bacteria even scarier is they have the ability to enter a metabolically dormant or viable but non-culturable state. This allows these Vibrio cells to turn into lifeless zombies and survive when environmental conditions aren't favorable. So what stresses these microbial villains out? Salt. These marine bacteria require some salt to grow, but too much can actually hurt them. Vibrio thrive in brackish, inshore environments, but sometimes events like tidal fluxes, rainfall, and freshwater releases can wash these cells offshore into the salty ocean water. So, what happens next? For my master's thesis research, I'm studying the effect of salinity, or the amount of salt in the water, on Vibrio vulnificus and its ability to enter this zombie survival state. To do this, I bring the ocean to the lab, and I subject my bacteria to different salt concentrations. Because these pathogens can't be seen with the naked eye, I have to use two different methods to visualize them. First, I grow them up on petri dishes. So healthy bacteria will grow and form a visible colony, while dead and dormant bacteria will not. I'm also using a fluorescent dye, and so this makes live cells glow green and dead cells glow red. So between these two methods, I will gain a better understanding of exactly what triggers the viable but non-culturable state, as well as if these bacteria can survive a trip out to sea. So, can different levels of salt turn Vibrio cells into zombies? And do they really pose a threat to local beachgoers? Well, I'm going to find out. Thank you.
Wow, okay. Everybody can now breathe. So this is the time when you can fill out your People's Choice ballots. What I'm going to do is introduce our students one at a time. If you would please hold your applause until the very end. What are you going to do? Hold your applause till the very end. Yes, students, when I announce your name, if you would please stand, face the auditorium, and just give a little wave. So basically you're reminding everybody of who you are, okay? Here we go. Emily Stark, the nose knows. What now? You know, we were doing so well. Thank you, Emily. You followed instructions beautifully. Christina Pimenta, Democracy in China. Julia Robler, Smell-O-Vision. Brian Mcmahon, Predicting Student Success. Natalie Bermudez, Moral Comfort in Nurses. Marissa Martinez, A Bird's Eye View. Nicole Reed, Game Time. Joseph Niederhauser, Secret Lives of Sparrows. Kirsty Tandberg, Marine Cancer Therapies. Nandini Singh, Sugar Code. Brianna DeGroot, Spotted Eagle Rays. Mikhail Gusenev, Positive Mentality. Rachel Bladow, Sea Turtle Development. Brian Conklin, Improving Memory. Bob Halstead, A Fish Story. Nicholas Davenport, Training the Brain. Rachel Salas, Singing Behavior in the Cardinal. Melissa Sannon, Who's Your Cody? Eric Nieves, Underwater Sensing. Felicia Cooper, Pulmonary Embolism Arising from Ovarian Cancer. Gabriela Tortolido, Finding the Feminist Between the Lines. Boris Tizak, Sea Turtle Sex Ratios. Michael Miller, Mission-Related Investing. Keith Murphy, Controlling Meal Size. Daniel Creed, You Are What You Read. Brandon McHenry, Zombie Bacteria. Now you can applaud. Woo! Very well done. Red Jackets, if you would please take this time to take up the ballots, the People's Choice ballots. Make sure you hand in your People's Choice ballots. Oh, hey, Nora, can I get one? If you have handed in your People's Choice ballot, we're going to take a break. We're going to take about a 5 to 7 minute break, and then we're going to come back for door prizes. Please use this time to stretch, use the restroom. And after you've done that, please come back in and we will hand out door prizes. If you did not receive a raffle ticket, make sure that you get one before we start the raffle. Thank you so much and see you in a few minutes. ma'am.
Because I was sick for the first live streaming, and I couldn't get here. Since you have to register for the live streaming, is there any way in the future we can look at the people who register for the live streaming being able to vote the people's choice? That's an excellent idea.
Just up here. Oh, there we go. Thank you. You know, the boys in the booth. I love you guys. I love you. Okay, ladies and gentlemen, while we are still tabulating scores, are you listening? Are you, they're not even, it's like my students. I don't know what's happening. We're gonna start with the door prizes, so get out your tickets. And if you're not here in the room when we call out the door prizes, I get them. This is a quick, okay, now this is about free food and drink, so you might want to listen to this. There's a reminder that there will be a reception in the grand ballroom following the awards. Did you hear that? There's a reception in the grand palm room, following the awards. A big thank you to the Gladys L. Davis Trust, the Department of Biological Sciences, and the Davamos Family Endowment for sponsoring our reception. Okay, the first door prize. Oh, I gotta put my glasses on. The first door prize is from the College for Design and Social Inquiry, OWL Design, 386643. 386643. Nope, moving on. Oh, okay. No, do you not watch game shows? You gotta be like, wow, I won! Right over here! Me, pick me! Yes, so if we can make sure that lovely lady gets the prize. Next up, we have Education is Key from the College of Education. I think in this is President Kelly's parking space for a full year. 386669. 386669. Yeah, see, look at that. Look, she knows how to do it. Okay. Number 3, Which Way to the Stage from the College of Arts and Letters, Department of Theater and Dance. It's a bag of kittens. 386829. 386829. Anyone? Yes. To the handsome young man in the black shirt. From the College of Business, we have Back to Business, 386707. 386707, yes. We have another gift bag from the College of Business. They're very generous over there. 386662. 6662. Does somebody have a 662? Yeah. Okay, now you're supposed to, like, you know, yell or something. This next gift is Pathways to Graduate Education from the Graduate College. 386732. 386732. This is for a slumber party at the Kelly family mansion on a Saturday night. 386732. Did somebody get it? Okay. Never too young to research. No, we aren't, are we? Office of Undergraduate Research and Inquiry, 386606. 386606. Anyone? Bueller? Bueller? All right, give me another one. 386603. Oh my gosh, it's my colleague, Catherine Johnston. But what she really wanted was a bag of kittens. And last but not least, from It's Owl Time, where I get all of my FAU pajamas and things. This is also for Dean Floyd's car. It's a BMW, it's white, it's parked out front. The keys are in this bag. 386637. Yes. Oh, I'm sorry, Dean Floyd. There goes your car. Now, were you guys listening when I was talking about the reception? Yes, okay. If you don't know where it is in the Grand Palm Room, if you follow, oh, I can't believe I gotta pick this up again. The red jackets will have this. You can follow them to the reception, okay? All right, we're back. We're waiting on the tally. Going back to tally, to tally, to tally. So I will take this time to talk about my show that I'm directing in the spring. It's called The Merry Wives of Windsor, and it was written by... You guys are so good. Yes, but we're kind of doing a spin on it. It's going to be the real Merry Housewives of Windsor. And it's going to be set in sort of a Palm Beach kind of setting. It's going to be opening mid-April. I'm the director. So it's gonna be awesome. Some of my cast maybe is sitting over here. We haven't had auditions yet. If anybody else would like to come and audition, please do. Have some definite performance potential going on over here in the Student 3MT Champion Selection. I'm just gonna stand here. I could sing a song. Who's my Lion King guy over there that wanted to do the Lion? Bob. Hey, Bob. So there was a comedian that did this whole thing about the Lion King, and his daughter was like, please, Daddy, please sing the Lion King before she'd go to bed. And, he didn't know the words, and so he would just sing, Pennsylvania, Oemoa, pink pajamas, penguins on the bottom, pink pajamas, penguins on the bottom. So now when you hear the Lion King, that's what's gonna come into your head, right? Right? I can't believe I'm up here singing the Lion King. You know, we have a math genius out here. I don't know why he's not in there counting. He's sitting out here, chilling out, while they're all in there going, 5, 6, 7, carry the 1. I have nothing. I have nothing. I'll just stand up here. So, Dr. Kelly, so many things I wanted to talk to you about. One of them is my student loans that I would like to discuss. I was thinking, I don't know if it'd be appropriate if we could maybe pass the hat. I mean, if everybody just put in $1, that'd be like my student loan payments for 2 months, right? What do you think? No? All right, I'll just come live with you. You got a big house. Who mows that yard? That's... I hear you're a big orchid collector, though. Yes? Do you tape them onto the trees? And you pantyhose them onto the tree. Yeah, the orchids on the, yeah, right. That got awkward. Why do you keep taking my picture? You know, I hear that there's Prosecco at this reception. Are the people that are sponsoring the reception here in the audience? No? They're over there drinking the Prosecco. How are we doing? I'm dying up here. Oh, for crying. Dr. Floyd, I have one word for you. Tenure. Thank you, I'm here all night. Literally. Okay, without further, I would like to bring up onto the stage the remarkable and wonderful Dr. Deborah Floyd. No, really, get up here. I mean, Dr. Montanez, next year, you're counting. All right. Do you want the judges on stage? Yes. Judges, can we have you on stage, please? Yes, big round of applause for our judges. If you are one of our awards scholar sponsors, if you would please stand over here on this side of the stage, which we in the theater call stage right. And everybody else who didn't fork over any money, but donated their wonderful time, if you could please stand over here. I mean, now that was a tease, wasn't it? So I think you're handing out the first.
Number 1, 2,
yes. Yeah. No, we're gonna go backwards. Yes. So we're going to be giving out the award for second runner-up.
Not yet.
What? Look, this is called filling. We're going to be giving out the awards for second and first runner-up. Our wonderful Tom Mersch, who sponsored these awards, will be handing out the award to the lucky students who are receiving. They're all like, please let us go. I wish I had more prizes to give out. Whoever gives me $1 can have lunch with me and pay for my lunch.
And your student lunch.
Yes! You in the back! We have a winner!
Here comes your Prosecco.
What?
Prosecco's on the way.
Where? Oh, no. That was just not nice. I got all excited. Okay, here we go.
She's got the money. She's got the money. Okay, so.
When in doubt, do a time step. Okay, Dr. Deborah Floyd with the awards.
Okay.
Here, give me the pencil.
Which do you want me to do? Oh, I hope I don't get this mess up. Okay, so you'll stand over me and watch this in hopes that I don't get this messed up. Annette, where is the piece of paper? You just took it. I promise this was organized. There you go. Thank you. I just need to have it certified. All right. So before we announce, because we do have winners, we didn't have ties. But before we do that, I want to also ask that we congratulate all of our competitors tonight. And all of our judges who are on the stage. And I'm going to take a personal privilege before I announce the winners to announce the coveted FAU 3MT Golden Hourglass Award. If you were at the competition last year, then you will remember that we began that award and that there are only 3 people worldwide that have that award. Our MC, Lynn McNutt. You can tell that she really deserves it. She's an MC extraordinaire. Our assistant dean and in charge of the 3MT program, Leanna Smith, had the award last year. And the one, the only, the extraordinary Zach Greathouse, also the man behind the camera. So I've asked our board chairman, Chairman Anthony Barber, to help me in awarding the special 3MT Golden Hourglass Award. Our first award this evening, now keep in mind there's only 3 people worldwide that have this. This is for extraordinary service for the FAU 3MT program. From the Harbor Branch Oceanographic Institute, there are 2 faculty that have led the competition for the last 2 years and participated in weekly 3MT steering meetings and brought a slew of students tonight to 3MT. And I'm going to ask that Dr. Peter McCarthy, if he would please come forward. And Dr. McCarthy, I'm going to also ask that you will also accept this on behalf of Dr. Joshua Voss, who, as we know, has been an extraordinary supporter of 3MT.
I mean, you know that this has taken a lot of work from staff and a lot of people, a lot of volunteers. I mentioned earlier in the program that the 3-minute thesis program was also a recruiting event for us, and we have a number of high school students and a number of folks that are here this evening, and this person has tabled for everything that we ever do and is there supporting 3-minute thesis and doing so in a fashion that really helps us recruiting. You're our best recruiters because your research is what really encourages people to participate in graduate programs. Nora Bergam, would you come forward and accept? You all know Nora, so you're now a member of this exclusive. And our final 3MT, the exclusive Hourglass Award that you can only get at this competition, and it's very difficult to be named to this, is someone that you also see behind the camera. If you come to graduate college events, celebration events and things, and all of a sudden this person just appears with a camera. She's an incredible volunteer and comes forward and really does help us in a lot of ways. And Teresa Crane, you're down there and you get to come up. And Zach, you get to take the photo. Thank you, Teresa. Thank you. Please Photoshop that one, will you? Okay.
Are you ready? Oh my gosh, I don't know how to do it. Thank you.
So our board chairman has your special award. So this evening, I'm going to ask Tom Mersch with the Kelly Cronenberg Attorneys at Law, a partner, if he would please come to the middle of the stage, because I'm going to announce the second runner-up, and his law firm has supported the 3-minute thesis and this particular scholarship. And our second runner-up and the winner of a $1,000 scholarship is from the Charles E. Schmidt College of Science, Brian Conklin, Integrated Biology. His advisor is Dr. Stephen Bressler. Congratulations. Thank you. I'm also going to ask if Tom would stay in the center because his firm has also generously sponsored the next scholarship as well. This is the first runner-up and the winner of a $1,500 scholarship to support his research. And this is also from the Charles E. Schmidt College of Science, Keith Murphy. And his professors, Dr. Ken Dawson-Scully and William John, are here this evening. Congratulations, Keith. Dr. Anastasia, if you will go to the center, please. And her Advanced Pediatrics of Boca has sponsored this next award, which is the award that you have selected, the People's Choice Award. And the winner of this award will win a $1,500 scholarship to support graduate research. And the winner of the People's Choice Award this year is Boris Tezia from Jeanette Quilty is the advisor, and Boris, congratulations. And now it is my pleasure to reintroduce to you this evening the Honorable President of Florida Atlantic University, President John Kelly. And President Kelly, the Kelly Family Scholarship Fund supported the inaugural 3-minute thesis winner last year, and is also generously supporting the scholarship for this year. This scholarship is a $3,500 scholarship to support research. $1,000 of that will be used for travel to go to Arkansas. I know that sounds strange, but that's where the competition is at the next level for the 3-minute thesis. And I'm pleased to announce to you and for the president to award the 2017 champion 3-minute thesis for Florida Atlantic University. Can we have a drum roll? All right. Boris Teziak. Congratulations. Congratulations. So you want them all to stay?
Okay, ladies and gentlemen, we have our champion winners. If chairs, yes, big round of applause, yes. For those of you that are advisors, trustees, deans, we're going to be doing some photos up here on the stage, so please join us. For the rest of you, please head over to the reception, and we will see you there. Where's our music?